let's pick up where we left off. I think last time we had the snow day. We were supposed to be taking the homework quiz. We'll do that today, but we'll do that, sounds like by popular request, after we come back from lunch. I don't know about the first 8 people that walked in. Well, we're not taking a vote anymore. You just should have gotten here quicker and asked first.
Wait, yeah, so this is not.
Huh?
We're having a set of freaking words.
Yeah.
Who's trying to pursue it?
I told you.
Do you guys have questions about anything that you want to talk about before we start?
Can we go over like what's on the house a little bit? Like just kind of like
I did my 1-15 homework before the snow day, so I had it done. So I haven't done the homework in like a week, so I'm a little
rusty.
yeah, rusty.
All right. So it's just 6-1 or 13-1 stuff. Okay. 13-1. That's it. Yeah, it should be very easy. So if you have can you, like, if I give you a function, can you type it in your calculator and get a graph out of it? Could you draw that graph on a piece of paper? Could you find the x-intercepts with your calculator?
Yeah.
Could you find the maximum minimum with your calculator?
Yeah, I can.
Sounds like you guys are going to do pretty well so far.
You need to show me how to do this.
Okay, I can
Let's see, what else is there? Oh, can you describe end behavior using the limit notations?
Yes.
Okay,
Infinity.
that's basically the quiz.
The limit notation is like negative infinity or positive infinity, right? And then it's like
It'd be something like this.
Yeah, I always want you know it's nice when you
Right? That's it. That's what we're talking about from 6-1. What do you guys think? Can you handle that?
I'm gonna figure out and see how I figure.
Yeah, sure, you might need to review the calculator thing, but like that's a great lunch thing. You just lunch party with your calculator. Right? We can handle that. So what else might you need? Let's see. Can you? Where was that? Shh. Could you look at a function like this and tell me how many zeros could there be? How many would you say?
Up to. What's that?
Yeah, at most.
and that's because that's the highest exponent.
Yep. And how many extrema then?
3 at most.
At most 3.
Wait, why is that?
It's 1 less than
It's
your
always 1 less.
Okay. Oh, okay.
Yep. Right? So that's basically the gist of 6-1, right? Is basically all just use your calculator, know your vocab and theorems kind of thing. None of the theorems are difficult or complicated, right? Yeah. All right. Does that feel okay?
Yeah, it's not. So we should just like go
Correct.
over section 1.
Just section 1.
Okay.
Just section 1. Okay. What were we doing in section 3? That's what the last thing we did, right?
You got past synthetic.
We did.
Yeah.
We did long division, we did synthetic division, we did rational roots theorems, we did the upper lower bound thing.
Yeah, that's where we're going.
We did find all the real zeros.
Yep, writing your rationals and then finding them.
Yeah, we did the whole shebang.
The whole page operation homework.
Yeah, that's a whole pager, probably. Do you guys have questions on homework stuff that you want to talk about?
Delta math and the rest of those problems are just, right?
Correct.
Sorry.
Yep. Okay. Well, let's just kind of continue. Let's just kind of continue moving on then into 13.4. All right. So, time to focus, please. 13.4. Talking about complex zeros in the fundamental theorem of algebra. So you remember that theorem we just talked about where how many zeros can something have? Well, we can actually do a little bit better than that. The fundamental theorem of algebra tells us that a polynomial of degree n will have exactly n complex zeros. That means that zero or real zeros or imaginary zeros, including multiplicities, but you'll have exactly n of them if we're counting everything. So if we're going to start finding imaginary solutions as well, right? Because the fundamental theorem of algebra tells us if we're going to find all the solutions, means we have to be looking for possibly imaginary things also. We have an important theorem called the complex conjugates theorem. And this one says that if you have one complex solution of the form a plus bi, then you also have to have its conjugate a minus bi. You guys remember what I is?
Negative 1 square root.
Yeah, good. So what's I squared then? Negative 1, right? So should remember that still from Algebra 2. So let's do an example. So this kind of a problem should come as, or sound familiar, because we did that, or did this same problem earlier, but we didn't have complex zeros going on in there. So let's say we want to write the polynomial with the lowest degree possible that has zeros of 1, -3, and then 1 plus I square root 2. God bless you. So these are our 3 zeros that are given, right? But I know there's actually a fourth one here. Why do I know there's actually a fourth one?
1 minus.
Yeah,
According to the complex.
yeah, exactly. Since that was a complex, zero, I know that if that's a solution, its conjugate also has to be a
Oh,
solution.
we're bringing back I.
Mhm.
Yeah. Well, oh, gosh.
I never really went away. You just stopped looking for him.
I don't know. I mean, just.
I mean, 5 plus 4 involves I.
And dude,
Because 5 is really the complex number 5 plus 0i. And 4 is the complex number 4 plus 0i.
Mr. Cool, like, I
It's
got
deeper.
no idea what
That looks like a smiley
Deeper. Because
Kind
zero
of.
times
So they-
Oh, that looks like
zero.
OJ.
Yeah.
Those are my initials.
Dang, you just got hit with it.
I'm just saying that it's never it's never really gone away. It's always been there. We just don't care about it most of the time. You know?
You just got hit with it.
All right. So how did we do this before? When we did this kind of a problem before, what did we do?
Subtract it over to the next side.
Yeah, we got to make everything equal to 0. Now, my suggestion for you is when we do this one, I would write it this way and pretend you're moving it all at once. And I'll show you why in a minute. But I think the arithmetic is a little bit easier if I think about it this way. I can take advantage of some nice difference of two squares things. Oh, sorry. That was supposed to be the plus sign there. Excuse me. Thank you. Good catch. Everybody's okay? Looks just like what we did before, right? What do we do after this? You multiply it all together, right? So you take all the left-hand sides and multiply them together. You take all the right-hand sides and multiply them together. Well, all the right-hand sides are just 0, and 0 times 0 is 0, so whatever there. So far, so good? Okay, now we got to FOIL this out. What order do you suppose I should do the foiling?
1 and 2.
I'm going to
3 and 4, and then.
I'm always going to FOIL the conjugate ones together, and then all the other stuff I'll worry about. So I'll FOIL that out. I'm just going to do that quickly in my head. And this one we're going to walk through how I would do the foiling here. Everybody good?
Yeah.
All right. So x times x squared. X times this,
Oh, that's a game changer.
and I'll do it this way.
You're not my boss.
Wow.
Stay in your own bubble. God.
Almost at the horizon. Oh.
Is everybody okay with how I foiled that out?
You can do some.
So I'm not going to cancel anything yet. What I'll do next is I'm going to, let's use a different color here. I'm going to distribute those x's through, and then I'm going to FOIL this stuff. And I guess I should make note that I'm going to push these negative signs through also at the same time. Everybody okay with that? Yeah, kind of. So there's me pushing that through. What do you notice happened there, though? The stuff with the eyes canceled out.
Exactly what we want.
That's what we're hoping for, right? And now let's look at that last piece that I still have to foil out. What do you notice about those two things there?
They're opposites.
They are conjugates, which means that's the same. To foil that, I can just use the difference of two squares factoring pattern.
Yeah.
So I can just write this as like 1 squared minus I square root 2 squared. And I don't have to really foil it out term by term. You can if you want to, but that's just a little shortcut. What is 1 squared? Okay. When I square root a product like that, how do I square a product?
Oh, don't you just cancel out?
Square root.
Well, I square both things, right?
Yeah, and then
And the square root of 2 squared is, well, this is, yeah, the I squared is -1, and the square root of 2 squared is just 2.
Got
Good for you.
that.
You're really excited about that. And
I'm trying to find things that are like, wow. I got it.
yeah.
Understood.
All right. And now let's group everything together here. So I have -x, -x, -x. That's minus 3x's. And then I have a 1 minus -2, which is 1 minus -2, 3.
One minus. I can't.
See the blue?
plus minus becomes a positive.
Oh.
Is that okay?
Oh no, this looks nice.
And now I just need to foil this out now. So x squared times x squared is x squared times -3x. And then x squared times 3.
plus 3x.
Okay. And then 2x times x squared is 2x times -3x. -6x squared. And then 2x times 3. And then one more step. Let's pick another color. Maybe we'll do this purpley color. That's fun. -3 times x squared is,
-3x squared.
and then -3 times -3x,
Plus 9x minus.
and then -3 times 3 is -9.
And now times the.
And we just group them together.
That's pretty hefty.
So that should be our final answer.
That's not the one. 13.4. For the test.
All right. Now let's go and do, yes, certainly. All right, let's try this one. So this is the same. Focus, please, focus. We've done this kind of problem before, right?
Yeah.
How do we start? Well, how many? Okay, sure. Set it equal to 0.
You want us to write that?
Three zeros.
Not up to. Only 2 is true. Let's go.
Well, actually now, since it says find all of the zeros, not just the reals, how many zeros are there? Exactly 3.
So what would be up to 3? What would it
Real.
find all the real
If it
zeros?
said, yes, real zeros, it would be up to.
Okay.
If it's all
And it's exactly.
or all complex, it's exactly, yeah.
That was according to that.
Yep. And that just stands for fundamental theorem of algebra. All right. The next thing we're going to do is use the rational roots theorem to figure out our possible rational zeros. How do we use that?
Find your degree,
I need the factors of the constant
your constant, and then your
and then my leading coefficient. So the factors of 1 is just 1. What are the factors of 36?
1, 2, 3, 4, 6, 12, 18,
Yeah. Except what are these really all?
plus.
Yeah, everything is plus or minus. I'm not going to worry about that here. I'm just going to do it at the end. So my possible rational zeros then are going to be plus or minus my
All your
constant terms divided by the leading coefficient. I'm not going to bother writing over 1 because
so you're just
so these numbers are going to be the candidates for my synthetic division. What am I just supposed to randomly pick a number? There's like 20 numbers here with all the pluses and minuses.
no, just do it, and then if it's possible, it's good.
Well, is there a way I can kind of like put my thumb on the scale here and
There's gotta be.
yeah, what if I just go and I graph this
Alright.
and then I look at the x-intercepts?
I feel like that's definitely.
Those should be the real zeros, right?
Yeah.
What do I have to be careful about when I'm doing this though?
You gotta make sure you plug it in right.
Well, sure.
That is it.
The other thing I need to be careful about, what does this real zero appear to be? -4, right? Is -4 on my list?
Yep.
Yes, that's what I need to be careful about. If I'm pulling a number that's not on my list,
Then that's mentioned. It's wrong.
it's probably an irrational zero, and the synthetic division is not going to work. You want to try to make sure you're using a number that is on the list. That's the point of making this list. That's why we just don't go to the graph and just pull the x-intercept.
If the number's not on that list.
Don't use it to do synthetic division. Because it
don't
won't.
use synthetic.
No, don't use that number to do the synthetic division with because it will not work.
Okay.
All right, so let's. So the synthetic division, we start by setting it up like this. What numbers go on the inside now?
Well, it's from our text. 1, 4, 9, 6.
Good.
So this is our conclusion.
What do you have to be careful about there?
Make sure you do it right.
Make sure the
Negatives
negatives
are
all
underneath.
You-
negatives.
Okay, sure, need to be careful about negatives, but there's something else.
Well, make sure you have all the spots with X's.
Yeah, if you skip a term,
Oh, then
what do you need to have?
you have
Zero.
You have to put a 0 in there. Very easy to forget that. Did we have to worry about it here? No, because we went from cubed, squared, x, constant, got them all. What's the trickiest one for Mr. Kulik to skip that's going to catch you every single time?
First
Well, you have to. The first one can't be leading coefficient of 0, or it's not a polynomial. It's the last one. If I leave off a constant term, it's like, oh, I got everything, and it's like, oh, no, you have to have an extra 0 at the end. Very sneaky.
Sneaky.
Wait, actually.
Yeah, sneaky little rascal.
Yeah, very sneaky thing to do. All right.
So you have there X2, 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 X0.
So we start by bringing the first number down. Then what do we do?
Multiply by
One
your
by
negative 4.
And then
Minus.
Add down.
Oh, wait, no, add.
add down, and then
Multiply again. Add down. Multiply again. Add down. Perfect.
and this is what we're looking for.
Yeah, you gotta put a
So what does that tell me then?
Let me write our equation.
So we had this, right? What can I do with that now because of the synthetic division that worked? Well, what factor does this have to have?
X plus 4.
X plus 4.
So you put
Where's the plus 4 coming
from
from?
that negative 4 right there.
From the negative 4 giving me remainder 0. Okay? What is the other factor that this has to multiply to?
X squared plus 9.
Good. Remember that this is constant x and x squared. All right. Now, if I apply the zero product property, can I solve each of these? Definitely, because one is linear, the other is quadratic. I can definitely solve each of these separately. So just subtract 4 from both sides. Surprise, surprise, negative 4 is a 0. Mr. Kulik, I knew that already. We saw it on the graph and confirmed it with the synthetic division. Big whoop. All right, x squared plus 9 equals 0. How are we going to solve that? Yeah, subtract the 9 over. Hit the square root, yup. When we square root both sides, what do we have to remember? Plus or minus. When I square root a negative, what do I have to remember? I. And then the square root of 9 is 3. So those are my 3 solutions. Negative 4, negative 3i, and positive 3i. Right? Notice that that is 2 separate solutions there. We've just written it as plus or minus. Okay? Is it time to stop? Or no, I have a few minutes.
4 minutes.
Okay. I heard people packing up and I got all discombobulated here.
Maximum zeros and wells.
You gotta be able to find zeros?
Yeah.
Just with your calculator, man. All right. Try doing this one
Type it in.
on your own. Get out your separate sheet of paper or in your notes or whatever. We'll go through it in a set. We'll go through it when we come back from lunch, and then we'll do the quiz. Sound good? So work on this one. When we come back from lunch, we'll go through it and then do the quiz. And then we need to talk about classes for next year for you guys, because I think you guys picked classes this week.
I have no idea.
That's why we're talking.
Well, that's why we'll talk about it.
You are making me so
That's you have to get my permission to take it from this course. We'll talk about all the options.
Why are you so sassy? What happened to his sass?
Huh? Just AP. Work on this example. I'm going to go through this now. So to do this. We set it equal to 0. Mandy, will you pull that door shut for me? Thanks. We know we're looking for 4 solutions. We're looking to find our possible rational zeros. We're looking for factors of 35. So that's 1, 5, 7, and 35. And then factors of 8, that's 1, 2, 4, and 8. So we have plus or minus 1, 5, 7, 35 over 1, and then 1 over 2, 5 over 2, 7 over 2, 35 over 2, and then 1 over 4, 5 over 4, 7 over 4, 35 over 4. What's up? Why are they what?
Why did they go over 2?
Zeros.
So it's going to be factors of the, yeah.
Here's like where the arrow is pointing.
Yeah, it's factors of the leading or the constant term divided by factors of the leading coefficient.
And it shows when you write it like that. Just how you have to write it. No, this is left arrow pointing down.
So that's my list. Yuckarooskies.
You have right limb and x equals 1 to 5. X is limb that's just how you have to write it.
So we go ahead and type it into my calculator now. Stop talking, please. So again, just typing this into my calculator. Gonna look at what I get, or the picture I get. What am I looking for on the picture? I'm looking for an x-intercept. So let's see, everything looks like it's happening between -2 and 1. So I'm just gonna kind of reshift my window there to get a better view. Okay. So I would say that looks like 1/2. Oops. Where'd my thing go? There it is. So that looks like 1/2, right?
Yeah.
This one looks like, if I'm looking at these, maybe 5/4, a little bit less than -1, right? So -5/4 maybe, is that?
Yeah.
So is this just like guessing, like you're not using a calculator?
I mean, you could, but I'm not going to use the time to do it.
Okay.
All right.
Are the zeros always, or like the x-intercept always to be something that was in the possible rational?
Well, the only ones I can use for the synthetic division are going to be the ones that are on that list. They could be an irrational number. It could be like the square root of 2 or something,
Okay.
in which case that's not going to be helpful. But I would still need to check it to see if, like, is that even close to something that's possible, right?
Okay.
So I don't know that that's -5/4. It looks like it might be. So I'll probably try it. The other one certainly looks like 1/2, positive 1/2,
Yeah.
right? But again, I don't know until I do the synthetic division to find out. What's that, 16? So that's what we're hoping for. Now keep in mind, what am I going to be getting after I do a synthetic division to a degree 4 polynomial? I'm going to get a degree 1 times a degree 3, right? Do I know how to factor degree 3 polynomial? Probably not, right? It's not like it's quadratic and I know that I always have the quadratic formula I can throw in the back of my pocket. So I'm going to just go ahead and do my next round of synthetic divisions.
Oh.
So 8 times negative 1.25 is negative 10. And then that is, oh boy, 20, no.
So, Mr. Cole, you're multiplying that number at the bottom, like that negative 32 by negative
1.25, yeah. So that's going to be positive 40, thank you, 56. And that does give me negative 70. Now we got something we can work with, right? So this, because it gave me a remainder 0, tells me that one factor is x minus 0.5. And then this, because it gave me a remainder 0, tells me I have x plus 1.25. And then this stuff, constant x and x squared, is going to give me the rest of my factor. Notice that that last piece is quadratic. So I know that I can always use the quadratic formula to take care of that. So I'm not going to bother trying to factor anymore. Bless you. I'm just going to go ahead and, oh my goodness, set that equal to 0 and solve that. I notice there's something I can do here first to this guy to make the quadratic formula a little bit easier to do. Yeah, no, I'm not going to factor. I'm just going to divide everything by 8. Because that's just going to make the numbers a little bit more convenient to plug into the quadratic formula, right? So negative b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. Is it my expectation that you remember the quadratic formula? Yes, sir. And then I have 16 minus 28. 16 minus 28 is negative 12. So I'm square rooting a negative. What does that mean I'm going to get?
Plus.
An I.
Oh my gosh.
And then I have to, can I simplify the square root of 12 at all? Yeah, so 12 is 4 times 3, and the square root of 12 is, or square root of 4 is just 2. And then I notice that I can reduce this. So if I divide 4 by 2, I get 2. If I divide 2i by 2, I get I. So there's my last 2 solutions. Okay, so here's the big takeaway. If I look at my graph, where was 2 plus or minus I root 3 on this picture? It's not there.
It's hidden.
You'll never be able to see the imaginary solutions on the picture.
Oh, it's imaginary.
The only way you can get them is to be able to do this synthetic division process down to where you can break it into a quadratic that you can use the quadratic formula on. It's the only way you're going to be able to get those. Is that okay?
Yeah.
That's the big takeaway. All right. There's that. So at this point, you guys should be able to finish up chapter 13. That was the last of it. So 44 to 53, I think that means.
Are you going for it?
And again, that'll go into Sunday's problem set. All right. So I want to talk just for a moment about the courses for next year. I'll put this up into on My Notre Dame also. I'll type it up and kind of put it in there. So there's basically, for those that are rising seniors, I think is the term,
Yeah.
current juniors, there's basically, you have 4 choices, but not everybody's going to be eligible for all 4 of them. Because there's prereqs and all that kind of stuff, right? Okay. So 2 of the courses, no prereq, anybody can take this. Math apps, personal finance is 1 semester each. So I think fall is the math apps and spring is the personal finance. And then accounting 1 and 2 also counts as a math class according to to Notre Dame. So either of those 2 courses anyone can take. They're going to be significantly easier than what we're doing right now. So if you are like, I'm not a math person, I got some other hard classes I'm planning on taking, you're trying to balance your schedule out so you don't like give yourself an aneurysm your senior year, might be a good option. I don't know who's going to be teaching them because they kind of bounce around a little bit. Option number 3, so that was options 1 and 2. Option number 3 is the IB Mathematics SL. So that's I think that's a 5.0 course, scale course. So if you're looking for GPAs, there's a IB exam at the end of it, so there's a possibility for college credit on that, maybe, depending. The prerequisite is a B or better, both semesters of oh boy, it says, I have this written down as honors, but I think that you're able to get in here. I think it's I have to look it up now. I thought I did this the right way. Apparently I didn't. 1 quick minute.
Business accounting area.
Okay. Yeah. Shh. So so for the IB mathematics course, it's a A- or better both semesters of this class, trig and pre-calc. That course is kind of a survey course. The first semester is a lot of statistics. And then the second semester will be a kind of a sampling of a bunch of other areas of mathematics. You'll get a little bit of calculus there at the very end. You'll redo some ideas that you've done potentially had done in Algebra 1 or Algebra 2 in this course. So it won't be, some of the ideas won't be a complete from zero. And then the fourth option is the AP statistics class. That's really something that's by instructor approval. So you need to talk to me individually about that. It's usually like an A
In
both semesters. It's like a hard A. As it's an AP level math class. So we're not joking around when you get to those. Does everybody feel okay?
Yeah, so those are the only options we have next year.
Yes.
I'm not.
What? They do, but you need to come from the honors Dragon Freak Out course to get to it. There's been rare exceptions in the past where students have come from here, but again, it's like instructor approval. It really has to be somebody that's gotten like A's on everything, like subtests included. I'm not sure who's going to be teaching it next year. I know Miss Moody started with it, but I think Miss Garcia has it now. I'm not sure. Yeah. All right.